Hi everyone. This class for 11AB elective. Today lesson gonna be vectors. I'm gonna give you more about formula and definition. First one is scalar multiplication of the vectors. Okay, let's take a look up here. If we have triangle PQR, okay, the triangle PQR, which is have vector mn have the same direction with the QR, sorry, mn same direction with the QR. Then and the m and n gonna be midpoint of the vector PQ and PR. Then you're gonna have QR, vector QR equal to 2 times QR, 2 times of vector mn. When you have the, for example, when you have the length of QR, right? Like you observe here, if this one no arrow at the top, that this one represent the length or distance. So at the same time, you can imply this one as a vector also, become vector QR equal to 2 times a vector mn. So if you want to, for vector QR, you want to call as a RQ, so gonna be opposite direction, then you have gonna be negative, gonna have the sign negative to mn, vector mn. Or either way, if you're gonna have, say, still keep QR, vector QR there, and then if you want to call vector mn become vector nm, right? So you're gonna have negative sign 2 times of nm also. So at the same time, when you talk about the length of mn, length of mn is a half of the length of QR. See that one. So you can imply as a vector also, become vector mn equal to 1 over 2 vector QR. So in this case, this is like this one, the length is a definition when you learn geometry. But now when we talk about vector, you put the arrow sign on the top. Okay, this one. At the same time, form this one. You can form the negative sign indicators that you can say have the vector BP, vector B equal to K and vector A. So K is a scalar, right? So if you compare with this one, right? So vector B is, for example, vector B is like a vector of Mn. And this K is, in this case, equal to 1 over 2 now. And vector A equal to Q, vector QR. Okay, so once K or scalar greater than 0, that means vector of A, B are the same direction. If scalar less than 0, gonna be opposite in direction. Okay, this one most of you know already. Okay, now we go next, the unit vectors. Unit vectors, like in this handout, they will use the sign like a vector A and have a little bit hat on the top. So equal to vector A over the distance of the vector A. So this is actually same with the last handout I gave, right? So this one, so the light down, this one is the vector of the length of vector u equal to 1, because unit vectors, the length of unit vector will equal to 1 always. Okay? Always going to be equal to 1. So for example, if I write it down in, say, vector A equal to 2i plus 3j, okay, and then a little hat on there. So once you find out the unit vectors, find the unit vector. So unit vector, okay, equal to 2i plus 3j over is scalar power 2. So become 2 power 2 plus 3 power 2. So equal to 2i plus 3j. This one have little hat on the top also, okay? Have little hat, I mean little arrow. And then over what? 2 power 2 plus 3 power 3, 9, 4 becomes square root 13. Then you can answer, leave this answer, or you can write it down, become 2 over square root 13 I, vector I, plus 3 over square root 13 J. Okay, so this is a final answer for unit vector of A, vector A, or unit vector of the in the direction of 2I, vector I plus 3 vector J. Okay, so this we like this one is a special unit vector form. But if you like the component form, right? So your vector A gonna be what? For like this one, right? You like in the component form, you're gonna have vector A equal to 2 and 3. So 2 is a value of x and 3 is a value of y. Okay, that's the handout before we do. Okay, but that's the same meaning for the unit vector. Now we see the example for the unit vector. Example, the diagram shows a grid with parallel line. AB, vector AB, okay, here equal to vector U. Don't forget, put the little hat when you lie or do the work. So PQ here equal to vector A. And MN or M should be somewhere because the missing the should be like this, okay, the grid. So M should be around here. So make it nicer. So M, these are M here. So M N equal to B. So direction, you see the arrow here. So M N equal to B, vector B here, and this is a vector. Okay. So now they want to, question A, they want us to express vector A and vector B in terms of U. In terms of U. So question A, you see, find the vector A and vector B in terms of U. So you can see A and B here, right? Vector A and B. And vector U here. You can observe vector PQ, right? Equal to how many times of AB? Because this have 2 units and this 1 unit. So PQ equal to 2AB, correct? Or AB is a half of PQ. Okay, so this one. Then AB, this one, because they have same direction, you see that. So both of them positive. So become 2, AB equal to vector U. And PQ equal to vector A. So now we got the first answer. Okay. Now we go to find next, finish question A now. Go example B. Example B. Question B. Express vector B in term of A. In term of A. In term of A. So from this one we can see A, B, U here. So you can see vector MN is a go opposite direction with the vector AB and the PQ. So we can say vector MN equal to how many times? 3 times of vector AB, correct? But they have opposite direction, you see, MN go this direction, but AB go this direction. You see the arrow, okay? So you're gonna have to line negative side down. So MN equal to vector B, okay, equal to minus 3. AB equal to vector U. So we got the answer for vector B. Now we want to find in terms of A, correct? In terms of A. Then this one vector U is a half of A, correct? You see, AB is a U. Is a half of A, correct? So minus 3 U is a half of PQ or vector A. So 1 over 2 of vector A. Okay, so we're gonna have okay. Now this is gonna be equal to minus 3 minus 3 over 2a vector a equal to minus 3 over vector a. Then we get the equation b. This is equation a. Okay, and then this equation b. Now go to c. Question c. If u is a unit vector, find the magnitude of the vector a and b and of v. That means find the length of vector a and the length of vector b. If u is a unit vector, right? So you can see this one. So that means if u as a unit vector, that means the length of vector u equal to 1. Okay. So now from this one we can get the find the vector a and b. So from here we can use here, right? So vector a, because from question a, vector a equal to 2 vector u. So if we find the length of vector a, gonna be the length of 2u, and this one we can write as like this one absolute. Okay, so now absolute 2 is a 2. The vector, the length of vector u equal to 1. So then equal to 2 unit. So answer is equal to 2 unit. Now find the length of vector b. We can use this one, right? Can use this one. So become what? Vector b equal to minus 3 vector b, right? So then write absolute down. So this one can write down, become negative 3 times with the length of the vector u. So become, because absolute, so become plus, and this one equal to 1. So equal to 3 units. Okay, so this definition or example of the unit vectors. Okay, so now we go next example. If you don't understand, see review the example. I just talk one more time. Okay, and we go next example. Okay. Okay, the next next definition or formula about the addition of vectors. Okay, I think this one most of you get used to already. The triangle law of addition. For example, if we have triangle P from here, PQR, 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 you see the direction PQ and QR gonna equal to PR. So we're gonna have vector PQ plus QR. You could see the common factor, the common point QQ, then equal to PR. Okay, this idea we're gonna use a lot when you solve the question. Okay, this one most of you know and we learned before. Now go next one. The paradigm law of the addition. So if we have paradigm PQRS, which is PS will equal to QP, or the vector PS will go the same direction with QR also. So then we're gonna have, once we have this one, PQR is a paradigm, then we're gonna have PS, vector PS plus PQ equal to PR, equal to vector PR. Okay, PQ plus PS equal to PR. And you can bring for this one to solve the question. One, we know this one is a paradigm. The paradigm, for sure, the opposite side should be the same length, right? And should be go to the same direction. That means PS, the length or even vector of PS equal to the length or vector of QR. And also PQ, vector PQ equal to vector SR and also the length. Okay, now we go next one. The definition, the next one, commutative law. This one the most popular. Okay, it's a similar to the first one. We just do the what they call the addition. I mean the triangle law of addition. Almost a similar idea. When we know this one, OACB is a paragons. This paragram. So the we're gonna know right away OA vector OA equal to vector BC and vector OB equal to vector AC. Okay. So in this case, if we give OA equal to vector A here and AC equal to vector B, then OC equal to vector C, then we consider the triangle OAC. We have three triangles here, right? So we consider the bottom one first, OAC, the triangle OAC. Gonna have what? Use from the triangle of addition. So we're gonna have OA plus AC. We have OA plus AC will equal to OC, vector OC. See, there's common point here. And at the same time, you see the triangle OBC, OBC, triangle OBC. So we're gonna have what? OB, vector OB plus BC. Common here, BB, so you equal to OC. Okay. So then, if then we replace the value of OB, I mean the vector OB represent with the vector B, small b. This one is the vector B. This is a vector B, okay? And BC is equal to vector A. Then you plus equal to OC is a vector C. And then you see on the top here, OA, vector OA equal to A, vector A. Plus AC equal to vector B. Equal to vector OC is C. So you can see this and this, the light color, the blue color here, the same. So we know this one equal, okay? So we can use this idea also to do the question. Okay, this another formula, or you can say formula definition for each kind of vectors. Then we go next example, okay? Next example. And for one more thing is, this one, we call cumulative law, right? If we have OA, vector OA plus vector A to A, what the meaning? Vector OA is a, right? A to A, that means it's a one, like a zero vector, which is equal to 0. So you see common here, AA, so equal to OA. So vector A plus 0 equal to vector A. So AA means 0 vector or equal like a dot vectors, no length, only a dot. Okay. Okay, now we go next definition, subtraction of vectors. Next definition about the subtraction of vectors. Okay, subtraction of vectors. See if you have the triangle PQR. If you have triangle PQR, PQQR, and then RP have the opposite direction with the rest of two vectors. Okay. So in this case, you can write, I think this one similar to the homework you did in the last handout. You can write down, say, PQ plus QR, right? Vector PQ plus Q, vectors QR. And then this one is what? Because the opposite, right? So you can have to minus PR. vector PR equal to 0. Okay, if for example you want to find vectors QR, right? You just move become plus PR minus vector PQ. Okay, so this similar we if you say you give the PQ equal to vector R small r and QR equal to vector small p, right? And then this one vector PR equal to Q. Then you just replace, right? So do the same way from here. You're gonna have become vector R plus P minus Q, because Q is the opposite side equal to 0. Then you want to find vector P. This is a, or say it wants to say find QR. Okay, this vector P. So equal to Q, vector Q minus vector R. Okay, so the same idea. So PR is a vector Q. So either way you can write down. Okay, so now I think we finished most of definition or formula. Now we come back to see some example here. Okay, example, see example 2 here. The diagram show a rectangle A, B, C, D with AB equal to 2 times of AD. Again, you see this one, AB to AD. This represent length, okay, because we don't have the arrow sign on the top of the AB and AD. So, but at the same time, we can apply this one as a vector AB equal to 2 of vector AD, right? When they give this message, can apply as a vector also. But you want to opposite, swap the direction like a BA, this AB, right? You want to swap become BA. So this one have to be equal to have negative sign. Okay, this is the first definition we just do that one, and we, okay. And now next, given M is a midpoint, M is a midpoint of DC. Midpoint, that means midpoint of CD, okay? M is a midpoint of CD, so CD. So we can say CM, the length of CM equal to the length of MD, which is, can say the vector of CM equal to the vector of MD also. Okay. Then next, express each of the following sums as a single vector. Question A. Now we want question A. Vector 5, vector AB plus BC plus MD. So from question A here, we can observe here right away, right? Everyone can see BB common point. So this one equal to AC right away. Okay, now we work on this. Vector AC plus MD. Vector MD. Then this one gonna be equal what? AC we don't know the length, but we keep in that way. So MD, but we know MD equal to CD, right? CD, MD, so MD equal to CM. Okay, because they're equal at the beginning, because CD, M is the midpoint of CD, so we know CM, vector CM equal to vectors MD. So we write AC plus, this one is what? MD equal to vector CM. See you common point here, CC, then this one equal to AM. So that's the final answer. Okay, now we see question B, do question B. B, vector AM plus M, vector MD plus DB. So this one really easy, but everyone see MM, so we got AD, right? And DD, you have this is MM, DD, okay? So now final, this one gonna be what? AB. See the common point M, D, then you got AB. So this is a final answer. Finish for this example. It's a triangle law, okay? Now see this example. Okay, next we're gonna go for the example number 3, okay? The example number 3, in the diagram OA here and OB here, OC equal to vector A and vector B and 2 vector B. So that means here OA equal to vector B and OB equal to vector B here. OC equal to 2B or OC. C is right at this point. Got this one. Didn't copy. So this is C. Okay. So then OC equal to vector B. That means from here to here. OC. Okay. OC equal to vector B. That means B is the midpoint of OC. So we can conclusion that the length of OB equal to the length of BC. At the same time, we can say the vectors of OB equal to the vector of BC. Okay, so this is OC. Arrow there. So now next, P and Q are points such that AP equal to 1 over 2 AB. So again, when this means length of AP equal to 1 over 2 length of AB. At the same time, from this message, we can apply as a vector of AP equal to 1 over 2 of the vector AB. Okay, and AQ, this is a length, right? It's a length or distance. So we can apply this as a vector AQ. Okay, we can apply this one as a vector AQ equal to 2 over 3 of the vector of AC. Okay, then this one. So we come back to here. AP equal to half of AB. AP equal to half of AB. That means P is the midpoint of AB. So then we can say AP, length AP equal to the length of PB, or at the same time, vector AP equal to the vector of PB. Now, we get all the information. So vector AQ equal to 2 over 3 AC, AQ 2 over 3 of AC. So we can say vectors QC become equal to 1 over 3 AC also. Okay, now we get all the data. Now we start to work the OP. So I use up here, vector OP. Okay, so you see vector OP. Okay, then we can draw the line. OP. So this is a vector OP. Okay, vector OP. So we can see, we can use the triangle of AOP or POB. Why? Because we have the data of OA and OB. So we can use either triangle of these two triangles, okay? Then if we use the triangle of the top one here, AOP, okay, so I like triangle of AOP, triangle of AOP. Then OP equal to OA plus AP. So OA plus AP, vector of AP. So you see the common factor, common point here, AA. So you got OP. So vector OA equal to OA here equal to vector A. So we write down plus AP. AP we got from here. AP equal to half of AB. So become 1/2 vector AB. Now see, we have to find vector AB. So AB, this one, AB. So we can use these two triangles, ABO or ABC. So I will use either one, okay? But I think this one gonna be easier when we use vector, triangle ABO, because we have data of OB and OA. But if you use this one, ABC, BC can use also, because we know BC, vector BC, and we know AC also, okay? Because we know AQ, then we know also know QC. But I use the this one better. So I use ABO, okay? Triangle ABO. So I have vector A plus 1/2 A. So I use this one become AO plus OB. AO, vector AO plus vector OB. Then see common point here, OO, we got AB. Okay, now become vector A plus 1/2 AO, but we have OA. We have vector OA, right? So OA equal to vector A. So we write down this is vector A, the same time. But this is the opposite direction, so you have to have minus here. And then plus OB equal to vector B. Now we simplify, become vector A minus 1/2 vector A plus 1/2 vector B. Then simplify these two vector A minus 1/2 vector A become 1/2 vector A plus 1/2 vector B. Now you can leave this as the answer, or you can get common factor, the coefficient, the common factor 1 or 2, that means the scalar out from the vector become A plus vector B. Can be either final answer, okay? So now we finish OP. Now we're gonna find out vector OQ. OQ, see which one we're gonna find. OQ where here? So we draw one line. OQ, draw one line here. OQ should be straight line, okay? So the direction here, that destination is going to be OQ. So in this case, you can use either, so far we can see this one triangle, OCQ or OAQ, correct? OCQ or OAQ. So I will use the top one because we know AQ. We know AQ from here. Question already give us here. We know AQ here. Okay. So or you can use the bottom or QC also, because we also know QC. Because when we have AQ equal to 2/3 AC, then QC gonna be 1/3 of vector AC also. But now I'm gonna use the triangle of AOQ. Triangle of AOQ. AOQ. So AOQ, I want to find OQ, okay? OQ, vector OQ, vector OQ. OQ, so I have OA plus AQ. So I have OA plus AQ. See again, common point AA, I have OQ equal to this. So now OA exactly same this one, OA, so equal to vector A. plus AQ we have from here. Vector AQ equal to 2 over 3 AC, right? So we write down 2 over 3 AC, vector AC. Now from here, we have to now see a vector AC here. So I can use the biggest triangle here, ACO, ACO, because I have data of OA and OC. So I use triangle ACO. So AC, AC. So become AO plus OC. Again, common point OC, OO, we got AC. Okay. From this gonna be A plus 2 over 3 and AO, but this is OA, so it's gonna be minus vector A plus OC, OC, so the whole thing equal to 2B, vector 2B. Now we simplify. So I write it down up here maybe. From here, I line up here, okay? So equal to vector A, simplify, become minus 2 over 3 vector A and plus 4 over 3 vector B. Then gonna be vector A, get the common vector A out. Okay. Oh, this one can combine. So become 3 minus 2. So we left 1 over 3 vector A plus 4 over 3 vector B. Okay, so that's a final answer for OQ. So this is the answer. Okay, so now we finish this example. Now we go next example number 4. Okay, next one, example 4, the last example, okay, for today. In the diagram, see in the diagram OAB, OAB is a triangle with OA here equal to vector A. And then OB equal to vector B. Vector B, M is a midpoint of OA. M is a midpoint of OA. So M midpoint, then we know OM, the length of OM equal to the length of MA. At the same time, we can conclude that vector OM equal to the vector MA. So we know the length, this one equal. And next is N is a point of AB. N is a point of AB, 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 okay? Such that AN equal to 1 over 3 AB, AN equal to 1 over 3 of AB. So again, this message, we can apply that vector AN equal to 1 over 3 AB. Okay, and AN, right? So we know at the same time we know NB, vector NB gonna be 2 over 3 of vector AB. Okay, and next NP is the point of intersection of ON and BM. So this is a P, intersection of these two lines. Next one is question give us vector OP equal to lambda of vector ON. OP is a lambda of ON. So lambda, this is like a K, the scalar, is the unknown. And BP, vector of BP equal to mu of BM, vector of BM. So this also scalar with assign as a like a k, right? So but this time assign as a mu. Then question want us to find OP in term of A, in term of lambda vector A and vector B. Okay, so then we can start to find OP, vector OP. But we can use from here because question give us that OP equal to lambda OQ, so we can write down OP equal to lambda of vector ON. So OP and ON. So we can find out ON, right? So the length or vector of ON here. So you can see either triangle of ONA or say AON or NOB. Okay, either triangle. But I think I may use the bottom one, maybe easier, or the top one. BNAN. Use the AN better, I think, because we know AN. Here we know AN, vector AN, and we know AO, so we can find ON. So I will use the triangle of AON, triangle AON. So then I have lambda, then ON, right? So I can have OA plus AN. So I have OA plus AN. Vector OA, vector AN. See common point AA, I got ON. Okay. So now lambda. So OA, vector OA, we have OA from here. Question already give us equal to vector A. So we replace with vector A. Plus AN. AN from here we have is 1/3 AB. 1/3 AB. Vector AB. Now lambda of vector A plus 1/3. Now vector AB. So we see the length or the side of AB here. So I can use the big triangle here, ABO, because I have this side data of OB and OA. So I replace this one. Okay, become AO plus OB. Vector AO plus OB. Common point OO got AB here. Okay, so I close. Now to the bottom here, lambda. This one gonna be vector A plus 1/3 vector AO, but we have OA, right? From the question give us AO. This go this side AO. So this gonna be vector A with the opposite side, so like negative. Plus OB. OB we have here vector B. Now equal to lambda A. Now we simplify, okay? So become minus 1/3 negative, right? And this one become plus 1/3 vector B. Now lambda. Now this one we simplify. Inside here become what? 3 minus 1 become 2/3 vector A plus 1/3 like 1/3 vector B. Okay. Then this one gonna be, then you simplify, right? Become 2 lambda over 3 vector A plus lambda over 3 vector B. Okay. Okay. So because right now lambda psi like a k is a scalar, so you can combine with a number here. Okay. So this is a final answer for OP for the question A in terms of lambda and vector A and B. Now we go question B in terms of mu and vector A and vector B. So so this one question A, okay? This is question A. Now we go question B. B, C, because we want to find in terms of mu. So find OP in terms of mu. So I have OP, what triangle we should use? OP, and then we have BP. So I can use this triangle though, because I have BP here. Okay, so I'm gonna use the triangle of BOP, triangle BOP, because I have this OB and I have BP, so I can get OP. Okay, now for that triangle, OP equal to OP equal to OP equal to OB plus BP, because I can use this data I have. So OB is a B, vector B, plus BP here equal to mu vector BM. So B plus mu BM, then I can use this triangle because quite clear, right? Because we have OB, OM, because M is a midpoint. So BM, I use triangle BOM, BOM. So become BO plus OM. See, common point OO, I got BM. Okay, so now this one gonna be vector B plus mu BO, but this one is a OB, right? So this gonna be opposite side, opposite direction, so become minus vector B. Okay, and then plus OM, M is a midpoint. We know OA, right? We know OA. So OM gonna be 1 over 2 of vector A. OM is a half of OA. Okay, because OA equal to A here. Now we simplify here. Vector B minus mu vector B plus mu over 2B. We can write this way, right? Because mu is a scalar, so we can combine with the 2. So this one get the common factor vector B out. So we're gonna have 1 minus mu vector B plus mu over 2 vector B. So this is gonna be the final answer for vector or P in terms of mu and vector A and B for question B. Okay, so I think that's all for all the definition and formula and the example. Now you review one more time, okay? And I will give you the question for practice. You check in the GC. I will give you the question very soon for the practicing. Okay, I think that's all for today. Anyway, if you have any question, you can contact me in GC or by the line group or individual group. It's okay. Okay. So I think that's all for today. See you next class for the extra question for vectors. Okay, that's all. Bye bye.